In this particular video, we are going to be looking at solving this particular problem, and we're going to give its domain, its range. We're going to determine if it's a function. We're going to fill out a table and write ordered pairs representing the points that you see on this data. Now, first of all, I'd like to say this does represent continuous data. And the reason is because the points are connected. Notice that I have a line that's connecting all the points. And the points are not just the dots that we see that are bolded. While those are the ones we're going to put in the table, every single point on this line, right? Imagine you have multiple points all connected in between these major points. Again, these are the ones I'm going to document, but this line, everywhere on this line represents a point on this graph. So we call that continuous data because all points are connected, forming this particular shape that we see. Now, I'm going to go ahead and I'm going to start. At first, we're going to go ahead and we're going to fill out our table with our points and our ordered pairs, and then we're going to give its domain and range and determine whether or not it's a function in that order. First, let's find the location of these points. Now, I'm going to go ahead and I'm going to write an ordered pair up here, and we're going to do them one at a time. Now, at this particular point, in order to find it right, we just start from origin, and I go over 1, 2, 3, 4, 5, 6, 7, 8, 9. It lines up with 9. I'm going to put a line right there, -9 on the x-axis. So for my x value, I'm going to put -9. Now for my y value, I'm going to go ahead and I'm going to find where it's located. And to me, it looks like it's at, if I start from origin, I go up 1, 2. And then it lines up with it. So we're going to go ahead and we're going to put a +2 for that value. So I'm going to write 2. Then we're going to go ahead and we're going to locate this point right here. So let me go ahead and write another set of parentheses for our next ordered pair. Now for my x value, I'm going to go ahead and look at the x-axis that goes left and right. And you know what, I just realized I should have done this 9 in orange because we're going to use orange for x. Now notice this one lines up right here at the 0 point. In other words, it lines up with origin for the x value. So my x value is going to be 0. And then my y value, in other words, how far we go up and down from origin, is going to be down 1, 2. So I'm going to put -2 for my y value. On this third point, let me put another ordered pair. Now for my x value, I'm going to go ahead and I'm going to count over from origin until it lines up to the right. 1, 2, 3. So notice at 3, go ahead and write a 3 right there. On the x-axis, it lines up, and it's a +3. And then for my y value, I'm going to go up from where their origin is, right there, right? Or you could even go up from here. 1, 2, 3, 4, 5, 6. And so that's going to be a +6 for my y value. Now we only have one point left to write an ordered pair, so I'm going to go ahead and do that. And if I'm talking about my x value, it's going to go over 1, 2, 3, 4, 5, 6. So this goes over to +6 on the x-axis. And for the y value, it goes up 1, 2, 3. So it lines up with 3 on my y-axis. Let's see, this one lined up with 6. I'm going to put a 6 there. This one lined up with -2, so I'll put a -2 there. So you can just see where I'm getting my numbers from. And so let's go ahead and write these ordered pairs out real quick over here, all in order. So I'm going to start from the furthest to the left, which is -9. For my x, we have -9, comma, 2. And then we had 0, -2, so 0, comma, -2. And then we had 3, 6. So I'm going to go ahead and put my 3, comma, 6. And the final one, we had 6, 3. So I'm going to put 6, 3. So there's our ordered pairs. If we were writing these major points that we have plotted on our graph, I would just write them out just like that. If we're writing this for our table, I would go ahead and I would put them in order, such as -9, and then we have 0 for x, we have 3 for x, and we have 6 for x. And then for my y values, we have 2 goes with the -9, -2 goes with the 0, 6 goes with the 3, and 3 goes with the 6. So you can just see it written in different ways. Now, we still haven't talked about the domain and range, but we're going to go ahead and we're going to do that now. Now, when I talk about domain, whenever we have continuous data, first of all, we're going to write it as an inequality. So in this particular problem, we're going to write it as an inequality, and we could also write it in what's known as set notation or interval notation, but this time we're going to do it as an inequality. And what I want to do is I want to find what is the furthest my graph goes to the left. And the furthest it went to the left on our x-axis was -9. So this is the furthest left. And all I did was just draw a line from the dot. So when we write the domain, if we're writing it as an inequality, we're going to put that furthest left value. Even if we're doing it in set notation or interval notation, we would do the same thing. We find our furthest left value and we put that first. So I'm going to go ahead and put -9. Now, because this is a closed dot, remember, if it's a closed dot, it means it touches it. So I'm going to use my less than or equal to symbol. And then I'm going to put x. And then we want to find what's the furthest it goes to the right. And the furthest it goes to the right, I'm going to draw a line down from that final point, is +6. So I'm going to say that x is going to be less than or equal to +6. And again, this is written as an inequality, but it tells anybody who looks at this value here, knows that we have a graph, and they know that the graph goes furthest to the left. The furthest to the left value is -9, and the furthest to the right value is +6. In other words, x is in between -9 and +6. Now, for the range, we're going to do it very similarly. What I want to do is find the furthest it goes down. Now, the furthest it went down was right here at -2. That is the lowest point on my graph. So I'm going to go ahead and start there. So we have -2. It was a closed dot, so we're going to use is less than or equal to. But in the case, instead of using an x, I'm going to use a y, because now we're talking about the range, right? The range is our y values. And then I want to see the furthest it goes up to the top. And the highest point on this graph is +6. So I'm going to say y has to be less than or equal to +6. And so now we have our two inequalities written, right? Our domain is x is going to be greater than or equal to -9, but less than or equal to 6. And for our range, the y value has to be greater than or equal to -2 and less than or equal to 6. The last thing we want to do is check and see whether or not this is a function. And for a function, what I'm going to do is what we call a vertical line test. And I'm actually going to just hold my pen up. A vertical line test just means if I have anything that's a vertical line and I run it across anywhere on the graph, it will never contact more than one x value at the same time. We don't care about y values, we only care about x values as we're doing this vertical line test. Now, I could pick any place to do a vertical line through it, but just for grins, I'm going to go ahead and just get me a highlighter, and I'm going to do my vertical line right through this area right here. But again, you could do this anywhere on it. And it has to follow the rule as that it can't touch more than one x value anywhere on the graph. So that's my vertical line test. I'm just going to label it vertical line test pass. So this tells me that this is a function. So I'm going to put it is a function. Now, if somebody would have not given us the graph, so we didn't have the image and where we could do a vertical line test and make sure that if I have a vertical line anywhere on it, that it only touches one x value at a time, and they give us a table, we could just simply look at all the x values on the table and make sure that they're not repeating. And for instance, there's no repeating x values. We have -9, 0, 3, 6, a different number each time. So that tells me that this is a function. If they had given me ordered pairs, I would look at the x values to verify that there are no repeating x values. And notice that each x value is a different value. And when I say x, right, I'm talking about the first number in each one of these is my x value. And so I would know just by looking at ordered pairs, it is a function. So this is just 3 different ways you can tell whether or not it's a function. If it's a graph, you do the vertical line test. If it's a table, make sure that there's no repeating x values. And I'm going to put on here x does not repeat. And same thing by looking at the ordered pairs. X does not repeat. So hopefully this refreshes your memory on how to write the domain and range of a function as an inequality, and how to determine whether a graph, table, or set of ordered pairs is a function or is not a function when it comes to continuous data.